Hi, listeners. It's Becca and Brooke with the College Admissions Insider podcast. We're here to remind you of Bucknell's application deadlines for this year.
For incoming first-year students, our Early Decision 1 deadline is November 1st. And for Early Decision 2 and Regular Decision applicants, our deadline is January 10th. We can't wait to meet you through your application. For the next little while on College Admissions Insider, we're doing a deep dive into academic disciplines, one episode at a time.
So far, we covered sciences, mathematics, the arts, and humanities, and we encourage you to jump back and listen to those episodes if you haven't yet. Today, we're exploring engineering. I'm Becca Haupt-Aldridge from Bucknell University.
And I'm Brooke Thames, also from Bucknell. On this episode of College Admissions Insider, we'll get to know the kinds of majors available in these disciplines, what engineering looks like in college, and the careers you can break into post-graduation.
Our guest is Erin Jablonski, Associate Dean of Bucknell's College of Engineering. Welcome to the podcast.
Hi. It's great to have you here, and we're so excited to talk about engineering with you today. And so we'll begin like we usually do, talking about you. Can you tell us what an Associate Dean does?
Sure. So first I'll introduce myself a little bit. I just wanted everyone to know who's listening. I am the first person in my immediate family to complete a 4-year degree, and my PhD is in chemical engineering. Before coming into the dean's office, I was a professor in the chemical engineering department, and this is now my 20th year at Bucknell. So that's a little bit about me. So you asked, what does an associate dean do? There are two kinds of associate deans on the academic side of the house at Bucknell: the associate deans of faculty, like I am, and the academic associate deans, who are the primary point of contact for our students. Associate deans of any variety support the dean in that unit, whether that means being a representative of your college or on a committee or being a sounding board for ideas and challenges as they come up. Every dean has a team of folks, and as does the provost, and they provide support like this. I don't have a typical day, if you're wondering about that, but I can say that in a week, I have about 20 hours of meetings, half planned, half timely problem solving, and the rest of my time is spent on initiatives in the college. For example, things like our Grand Challenges Scholars Program.
Thanks for providing an awesome overview. We are thrilled to have your 20 years plus of experience here with us on the podcast. Maybe without any spoilers, can you give us a little hint about the Grand Challenges Scholars Program?
Sure. So the Grand Challenges Scholars Program was started by the National Academy of Engineering, and it's a way of developing competencies in our students. And when they complete these competencies and do a report and sort of a final display of what they have worked on as they move through their path in their engineering curriculum or other curricula, it is available to non-engineers. They end up with a signed letter by the president of the National Academy, and they get recognition. It goes on your resume. It's a really great way to build in more purposeful activity during your undergraduate time.
Awesome. Thanks for sharing. And so before diving in, I'd like to give our listeners a bird's eye view of engineering. What should students know about the field in general?
I may be biased, but I think that engineering is really a calling. The whole point of engineering is for engineers to use their skills to create things that benefit society. Those things might be machines, those things might be software, they might be infrastructure, or really anything that needs to be designed and built.
And so with that kind of general overview, how might a student know if engineering, by that description, is a good fit for them?
Well, to start with, a lot of high school students will hear something like, you're really good at math and science, you should consider engineering. This is the most common language we hear from students coming out of high school who have been recommended to consider an engineering undergraduate degree. And while that is often true, math and science skills definitely help you out as an engineer, it is not the whole truth. Engineers should also be folks who want to try new things, who enjoy thinking about really hard problems with a lot of potential solutions, and who can communicate their ideas to others. It's fine to have a great idea, but if you can't explain it to anyone else, it's going to have a hard time getting anywhere. Teamwork is also a significant component of engineering. You get to work with other people with different skills and backgrounds to come up with the best solution. That is the one that provides the greatest societal benefit. What's really important about the program at a place like Bucknell is we encourage collaboration, that teamwork, working with others, coming up with the best solution using everyone's skills and experiences rather than competition. It's important when you're looking at programs, think about, is this a place that is going to welcome me in and try to keep me here working with other folks, or am I going to feel like there's a lot of competition that's driving the way that I work?
And that's so important for when a student thinks about the type of experience that they want to have. It sounds like Bucknell really is truly collaborative in that nature. So now that we have that down, can you give us an overview of the different majors a student might see at an engineering school?
Sure. So like a lot of schools, Bucknell offers a variety of engineering majors. We have biomedical, chemical, civil, environmental, mechanical, and then the ones we often get asked about because they can be harder to distinguish: electrical engineering versus computer science engineering. The easiest way to think about this is electrical is more device focused. Computer engineering is about optimizing the pairing of devices and software, and to some extent to think about the tools of augmented reality or virtual reality. And computer science engineering is much closer to software development. And for a lot of listeners, that is going to translate to things like game design and applications in augmented or virtual reality.
Thanks for going over all of those. I'd like to slow that down maybe even a little bit more and get into the nitty-gritty of the differences between computer engineering, computer science engineering, and a computer science major that you'd maybe find in the arts and sciences like we do at Bucknell. So what's all of the difference between those things there?
Sure. Most importantly, none of these are mutually exclusive. And I would say to anyone considering any of these majors, don't sweat it. You can get any job in the space with any of these degrees. But I'll just go into a little bit the different flavors of the majors involving the word computer, because they do represent different amounts of depth and breadth. The way I like to describe the spectrum is going from proximity to hardware through to proximity to people. In the engineering realm, you're going to get a solid understanding of how devices and software function, as well as learn things like network architecture, for example. In the Computer Science Bachelor of Science, or BS program, you'll develop skills to code and develop user interfaces. But with the Computer Science Bachelor of Arts, you'll have fewer overall required courses in the major, so you have a lot more opportunity to craft more of your own journey through Bucknell. So depending on what is most important to you, or if you want to come up with a complementary minor, major, whatever it might be, there's different options available, and you should take a look at all of them when you think about what is most important for you in your studies.
Thanks for that clarification.
That is so helpful, and something I know we'll absolutely be using as our admissions counselors are out on the road and chatting with prospective high school students. And so knowing that Bucknell is a liberal arts university, but the fact that we have a College of Engineering makes us somewhat unique, right? How do the liberal arts intersect with engineering at a school like this?
That's a fantastic question. And I want to say one of the things you should know when you go to a liberal arts university that has a College of Engineering, the faculty and staff in the College of Engineering have chosen to be at a place like this because they value so much the broad perspective that you get from being not just in a purely technical space. So where we started this conversation was engineers use their skills to create things that benefit society, and that is a fairly lofty thing to say. I think to do it well, you have to develop really a strong personal ethical framework. You have to practice cultural humility. You have to be a responsible global citizen. You have to understand how the world works outside of equations and experiments so that what you design and build as an engineer has real value for the people you want to serve and the planet. So absent the liberal arts context, I think you can miss out on a lot of that knowledge, a lot of that exposure, even the kind that is gained outside of courses. Our campus offers a spectacularly wide array of speakers, performances, clubs, events. All of these round out a person and better prepare them for a life and professional career outside the university.
It's great that students at a school like Bucknell will get to interact with disciplines outside of engineering. Can you tell us about majors within the College of Engineering that intersect together?
Sure. So the great thing about our engineering curriculum is the first semester is a common semester. So you are with all the other types of engineers and some very few brave folks who are thinking about transferring into engineering. That is your first experience. Identity as an engineer first, not as a person in a specific discipline. Then as you move through the curricula, you have opportunity to take electives with other majors. You have some courses where it may be cross-listed. And so that's a great chance to work with folks outside your discipline. And then we have an interdisciplinary senior design program where you can join a course with engineers from across the disciplines to work on a project for a whole year with an industry client from outside the university on a real problem that they're going to implement at their place of business. And so that can be a completely transformative experience for our students, not only working with other majors, but working with a real client on a meaningful project that has a chance to be implemented in the workplace.
Another note about liberal arts colleges and universities is that they can be a lot smaller than research universities. Is that a drawback for engineering students at all, or does a small school also have its benefits?
So at Bucknell, our size and focus on undergraduate education is absolutely a benefit for undergraduate students. For example, in just one department, chemical engineering, any undergraduate student who wants to do a research project is guaranteed to be able to. And in every department, there are research opportunities both during the academic year and in the summer. We often have over 100 students here in the summer doing research with a faculty advisor, and many of those students go on to present their work at national conferences. So we have students who are co-authors on journal articles, students who complete honors theses. All of this is a really great experience. So if you want to do research as an undergraduate, this is the place to be.
So what exactly does research look like at a school like Bucknell?
If you're working with a research advisor who does lab-based applied research, it often means you're working in a lab with materials and equipment to prototype designs and run trials or experiments. If you're working on a software or database project or something where you're pulling a lot of data together to make a case, for example, using highway crash data to make recommendations about road safety policies, then a lot of your work is going to be on the computer. But in both cases, you'll have frequent discussions with others in your research group and your advisor, and you'll often be asked to communicate those results to a broader audience.
What about internships or even co-ops? I know those are really important for students in a variety of disciplines. Is that true for engineers as well?
Absolutely. Engineers want to get some real world work experience before they go out looking for their first job. So internships are the most common way we see our students doing that. You see them doing it most often in the summer before their senior year, but we definitely have students who do them after their first, second year, and so forth. If you do happen to get a great internship before your senior year, sometimes that can even lead to a job offer, which is great for a student's future plans. I will say it is not always great for a student's motivation in the senior year, but that's a different podcast. Bucknell does a really good job with our 4-year graduation rate. That's an important distinction among a lot of engineering programs. So we will make sure you have the courses that you need, and we will make sure that you're advancing in the curriculum. Because of that, we don't have a co-op program. We do encourage those summer internships to use the time between the academic years to go get that work experience. We also have a very robust offering of client-based, not only senior design projects, but projects and other courses and electives. So students get to work directly with industry partners on challenges that they typically investigate over the course of a semester or a year. And so this is another way that students are exposed to different employers and career paths, and another way they might get a job offer.
And so I guess by design, your 4 years at a school like Bucknell studying engineering is preparing you for some really terrific career outcomes upon graduation. Switching directions just a little bit, we know the engineering field can be rigorous, and our students over those 4 years are busy. Are engineering students simply students, or do they have room to be involved in other interests outside the classroom?
In defense of all of my colleagues at this university, every single major here is rigorous. You could get so much out of anything you study at a place like Bucknell. So for all of us, it's really important that every Bucknell student gets to experience everything the university has to offer. So we do want them to get out and do things well beyond just engineering. And we see that. We have some amazing performers. We have musicians and dancers. We have students join club or intramural sports. I think we have almost 20% of our engineering students in Division I sports. We also encourage our students to study abroad. Unfortunately, it's often the message that engineers won't have time in their schedule to study abroad, but we really make it feasible even within their packed curricula. And so what I would encourage everyone to do is wherever you end up being an engineering student or any type of student, stay a whole person. Make sure you get out and explore your interests well beyond your major, take advantage of everything that your institution has to offer, and make sure you're at a place that really encourages you to do so.
That sounds like part of a really great pitch why a student might consider being an engineer at a school like Bucknell. I would love to end this episode with your best pitch for why engineering.
I think an engineering degree really prepares you for anything in life, truly any career, and that is what we see. Our students go off to a wide variety of jobs or graduate school. The interesting thing about engineering is that you work in the technology space, so you know that big chunks of whatever you learn in school are going to be obsolete within a few years of graduating. And that's just down to the pace of change we're seeing in industry. So engineers need to learn how to think critically, to understand context, and to be independent, truly lifelong learners. And then you always have your technical skills and your quantitative reasoning to fall back on. As everything becomes more data-driven, that engineering-trained mindset is an ideal one to take on any type of analytical decision-making work. And that can happen in any industry, in any career path.
Well, I think I want to be a Bucknell engineer. I'm sold. And I'm sure our listeners have really appreciated all of the value that you've brought to this episode. So thanks again for joining us.
Yeah, thank you for having me. I could talk about how much I love engineering for a few more hours.
And thanks to everyone out there for listening. If you're a fan of the podcast, please take a moment to rate, subscribe, and share this episode with the students and families in your life.
We'll be back with another episode in a few weeks. In the meantime, send your questions, comments, and episode ideas to podcast@bucknell.edu. We read every note you send.
And finally, you're invited to follow Bucknell on your favorite social media apps. Just look for @BucknellU on Instagram, Facebook, Twitter, YouTube, and TikTok. You can also follow our student-run Instagram account and see some of our amazing engineers at @IamRayBucknell.
Until next time, keep reaching for your dreams and your dream school.